vector functions can be used to model things that we see in real life. Very good example. What does that remind you of?
A solenoid.
Huh? Go ahead.
A solenoid.
A solenoid. Enlighten us, Haley. What's the solenoid?
It's in physics where it's a bunch of coiled wires that are essentially in a loop, but you can have the loop.
Doesn't a solenoid need something in the middle?
I mean, it has a B field.
Huh?
It has a B field.
It has a field, right? Solenoid is a good example. Another one in construction or other cases, a spring, right? Box spring. And that is three-dimensional, it is a space curve. This can be modeled using sines and cosines. And one of them would be linear if you have to take a guess which part will be linear. So which axis?
Z.
Z. This is going to be linear. The other two will be in terms of sine and cosine. That's one. In biology, protein structures. Was there anyone here interested in protein structures? No. You might encounter it later since you're.
Yeah, in the summer, I gotta take biochem.
Okay, so you will encounter. Proteins have the tendency, proteins, they fold. The reason why proteins fold is because things need to be packed really tight inside the cell. And same happens with another, which is DNA. So folding, make sure that you have a lot of material in terms of protein in a very compact space. So if you want to model structures of that proteins and stuff, you need to represent them in 3 dimensions. Computation is very difficult. That said, last time I mentioned that if we have the function, vector function, r of t, which has 3 parts, f of t, g of t, h of t. This is the same as writing f of t, I vector, g of t, j vector, h of t, k vector. T is our parameter. T is what we will use to trace the curve, right? We know that. At the end, I said if you have to take the limit of some sort of a curve, all we have to do is put the limit here, there, and there, right? And Chris asked me, well, that doesn't make any sense because derivatives don't work that way. But we're not finding the derivative yet. Rather, we are simply applying a limit. Now, why is it true? Why is it possible for me to simply take the limit of each of the components? Let's say I take the limit on both sides. Limit t approaches some number, c, r of t. In that equation, limit t approaches c, some number, f of t, I vector, g of t, j vector, h of t, k vector. Yes? Property of limits. Which is,
Limits are distributed.
we simply distribute the limit, right? So the limit gets applied to that term, and that term, which is the same as saying apply the limit to each of the components. Good? Okay. One of the things that we need to know is the domain of a function in general. Do you agree? If we don't know the domain, then we might have asymptotes, which require additional attention. So if you have a vector function, you can find its domain also. I'll do one in limit 2. When we take domain in 2D case, the set of all x values, range set of all y values. Here, if you have to define the domain of that entire vector function, what should you use? I'll do it right there. I'll give you a hint. It is a beverage. Tea. So T is the parameter. T is going to define the range for us where each of these functions will exist. Well, which means we know how to define T. You know, the x values in 3D space. That is the way to think about the domain of a vector function. So in our case, sine t, what is the domain? Not the range, domain. All real numbers, okay? Sine t, the domain. You can put any value, negative infinity to positive infinity. What about t?
Same thing.
Same thing. I can plug in any value, negative infinity, positive infinity. What about e raised to?
Same thing.
Same thing. Negative infinity, positive infinity. Do you see any restrictions? No. So the domain of this particular vector function is
Same common numbers.
In other words, I can put any value of t and those vector components will exist. Agree? Okay, what about the range? Oh,
-1 to 1. Or wait. Well, that's tough because which axis are we referring to?
very true. So the issue when we come up with a range is the range depends on each of those components. If I simply look at the x component, no matter what value of t I plug in, I am going to go between -1 and 1. Yes, right here, sine wave in this direction. If I looked at the y component, it will go from negative infinity all the way up to positive infinity because it is a straight line. And the last one, it is e raised to, which will go from negative infinity to positive infinity. Agree? Why not?
Because
No, I mean, the domain is from negative infinity up to positive infinity. What is the range? 0.
not
to-
inclusive.
Yeah, not including 0. Good. Okay. So going back to here, the range of sine t I should have just drawn a new coordinate plane. It's okay. My brain is acting in a weird way today. So if I look at the x values, I am bounded by one, -1, yes, along this way. So as I vary t, the curve is simply going to go in that manner. Agreed with me so far? Okay. If I plug in any value for y, it is going to take on, or it'll go this way, right? It's going through the origin, it will be a line, exponential, it is a z component, and it's just going to blow up that way. But if you want to define the entire function, it should be a space that is constrained for or by the ranges of all three. Agreed? So if I want to define this function, all the components will be wrapped up in that area. Do you agree? Reason being, I want the x component to fit in that place, which would mean the other two must be accommodated in the same range. Even though they can exist outside, we want to limit it because one of them cannot go past that. Good? So when we come up with a range, it is not as easy as finding the domain. Reason being, each component will play a part in coming up with the range. Good? The B example that I used last time, its range was the entire 3D space. It can keep on flying wherever it wants, no restrictions at all. In that case, the range negative infinity to positive infinity. Good. Think about it this way. If I put that B inside this classroom, and if this classroom is a cube with length 4 units, width 4 units, height 4 units, it's limited within the bounds of that cube. Thank you.
So I just wanted to see what I was thinking was right. So if you considered each of the ranges of the components as a set, then the range of the entire vector function would be the union of all
Yes.
three? Okay. Just check.
Yeah, but if I ask you where will the function exist, then it will exist in the part that is common to all of them, in which case it would be the intersection, because each component can only exist in a certain space. So since x is limited by -1 and 1, I draw it. I think it should go this way. -1 and 1, my bad. Rotated. I just put the wrong letters. How about that? So -1 and 1, it should be this way.
You could have just changed the axis.
I could have, right? As I said, my brain is working in a weird way today. So done. -1, 1, oh, -1, 1. So since we are constraining x, the others will also be constrained. Good. Here, I looked at the values that will work for that. I looked at the values that will work for that. I looked at the values that will work for that. Put them all together. So this would simply be in terms of sets. Union. Good. Good. Union of those three sets will give you that. Are we clear?
What happened if one of them, say, t, could only go to like -3,
Only -3.
like -3 to infinity?
It's still a union, right? There is a number. As I said, with the domain, we don't have a problem. But if it is the range, that's when we end up having problems. I can plug in values, let's say, what is an example? Let's take this one. T plus 2 ln of t square root of t. 3 cases. Now, can all of them exist from negative infinity? If I look at ln of t plus 1, just as a function, what is the domain of ln of t plus 1? So the component here is ln of t plus 1. Domain
-1 to infinity.
-1 to infinity. What is that?
Sorry,
Why is that?
because you can, well, ln of 0 doesn't exist, and so you just set t plus 1 equals 0.
So the rationale here is we require t plus 1 to be greater than 0, right? It just can't be a negative number. So whatever that is in here has to be greater than 0. Of course, less than infinity, which would mean t is greater than -1. Agree? Okay. We'll leave it as is. We can get to the interval notation later. The next one, t over square root of 9 minus t squared. That is a function that has a radical and it has a ratio. Rational. Is that going to cause problems, or is that component going to have any problems? Yes, because the denominator will become 0 for certain values of t. How do we find that? We simply set 9 minus t squared. We want it to be greater than 0, which would mean t squared has to be greater than -9, which would also mean t squared is less than 9. Take the square root on both sides. T has to be less than 3, and when you take the square root, plus or minus, right? So 3 or greater than -3. In other words, it is less than 3 this way. Greater than -3 would mean you're going from -3 all the way up to 3. So if we combine them together, I can simply write it as t has to be between -3 and +3. Agree? For any other number outside of that, you would end up having an imaginary number. So ln of t plus 1. That leaves us with one component, which is 2 raised t. What about 2 raised t? Does it have any restrictions? Can I plug in 0 for t? Yes. Can I plug in -10 for t? Yes. Can I plug in -1000 for t? Yes. Can I plug in +1000 for t? Yes. So no issues there. Negative infinity. Again, if we want to define this function somehow in 3D space, not requiring the other components, would simply mean it is going to lie on one plane. Want it to be something that is common to all 3. In other words, if we restrict to the case that whatever domain that I come up with guarantees that the first one exists, second exists, third exists, we can't simply do the union, we have to do the intersection. Easier way to recognize that intersection. I recommend this, but entirely up to you. Start with ln of t. So 2 raised t exists from negative infinity all the way up to positive infinity. Erase this. Two raised thing, not a problem. I'll include everything. The second one, y component, can only exist between -3 and 3. So, not inclusive. So I'm going to put, we do not open dot, close dot, right? Yes, okay. 0 here. Dot, -3, +3. The last one, x component, has to be greater than -1. Different color. -3 is here, -1 there. Close dot, open dot, open. -1. What is the overlapping part? If I restrict to the case that all 3 of them has to exist.
-1 to 3, not inclusive.
-1 to 3, not including 1 and 3. So in this case, t would be from -1 up to 3, not including -1 and 3. So we have 3 functions, 2 of them are trigonometric. That's rational. Numerator is not going to cause any problems whatsoever because it's just t plus 1. But the denominator, if it becomes 0, we will have an issue. So we require t minus 2 to be greater than 0, which would mean t has to be greater than 2. Good. So, first one. I'll do the last one, we can come back to the middle. To cosine 2t. Is there a t that is going to cause problems here? No, I can plug in anything I want, life's great. So then comes sine t. If it is just sine t, is it an issue in terms of t? No, sine wave keeps on going this way, not a big deal. We saw it earlier, but it is in the denominator. So there are places where the denominator will become 0, which will present an issue. So what are those cases? Well, let's start with that case. We are restricting already. So things have to be bigger than 2. Do we agree? Because it's the first component. So I'll put 2 there, a 0 there, 2. Yes.
I have a question. Can it be t be less than 2, bigger or less than 2? Not 2, just bigger or.
Thank you. You are right. I am sorry. So union t less than 2. I can write it this way: negative infinity to 2, union 2 to infinity, because the only one that's going to cause problems is exactly odd. So I have to move this now. Zero, 2, everything on this side possible. Everything on that side possible. For cosine negative infinity to infinity possible. Good. That leaves us with the last part, sine. Now, the problem here is sine's going to become 0 for different values of t. Between 0 and 2 pi. Sine 0 is 0. 0 to 2 pi. There is another point where sine will become 0, which is
Pi.
How about pi?
Sine is 0.
Sine pi,
Sine of pi, oh yes, sorry.
right? Sine pi 0. Sine 2 pi 0. Sine 3 pi 0. Sine 4 pi 0. Yes? But I'll have to exclude everything. Every pi. Right? So for all pi values, sine is going to produce 0 and I have to exclude. So I can generalize this. You can either use n, k, doesn't matter. So for any t equals, should we use n or k? N, I like n. N pi, where n equals make all whole numbers, so good, I can put in any value, which would simply mean I will have to exclude 0. Because of that. Where does pi lie? Somewhere here, yes. And then I would have 2 pi somewhere over there, 3 pi somewhere over there, keep on going. On this side, negative pi, negative 2 pi, negative 3 pi. Yes. So, how do we write each of those pieces? You can recognize a passing. So, negative infinity to union of all the sets that are between, say, if I call that to be pi, this would be n minus 1 pi. Agree? Yes, no? So I can call this to be the union of all numbers that lie between n minus 1 pi and n pi. Do you agree? For any value of n. So pi, 2 pi, 3 pi, negative pi, negative 2 pi, negative 3 pi. Yes. So depending on the value of any pi, I'm going to include everything that's fall between n minus 1 pi and n pi. That is the first set. Do we agree? So far, so good. Minus 3 pi to minus 2 pi, minus 2 pi to minus pi. Same on the other side. Should we include 0?
Or do you mean in the exclusion, including 0?
So if I did union in the range, so I'm including everything that is between here and there. So let's write it this way. T has to be between n minus 1 pi and n pi, right? For any value of n that you plug in. Can it include 0? No. If n is 1, this would be 0 pi, which is 0. I'm not including, agree. That's just 1 pi. So that 0 is taken care of by this. Yes, no, maybe. Okay. 2. Now that is a problem. Agree? We cannot have 2, but 2 will fall between 0 and pi. I put the union the wrong place. Can I erase this? Extra bit of knowledge, I guess. Are we good so far? Good. So what I've done is I'm saying that I can pick this, I can pick that, I can pick that, I can pick that. Put them all together and we are great for the values of t. But there is only one other number that's going to cause the issues. It is that one. So since that is for one case, I can write it this way. T is in the union, I'll use K or N. If I start at negative infinity, end at positive infinity, I can go from negative infinity all the way up to positive infinity, include everything is because that's all I'm doing. I'm doing union. Negative infinity, positive infinity. What is the interval? This. Yes. That is my set. I'm taking the union of all of those. If things are difficult to see, just start from -1 to +1. If it is -1, you're saying -2 pi to -pi, yes? When it is 0, -pi to 0. And when it's +1, 0 to pi. Yes, if you restrict it to just 3 values, n is equal to -1, 0, 1. You will be including this one, that one, and that one. Just write it at home. Do negative, start at -3, go all the way up to 3. See what pieces you get. You'll include this, that. Good. Like that.
What about the 2?
I'm getting there. So we have did this. Again, there is only one number that we need to consider here, which is 2. Since it is just a single number, and that. Do we remember what set operation is that?
Subtraction.
Another way. After the letter D.
Do-
Derivative.
No, I didn't, no, I did it, I'm doing
Another word for subtraction.
or no, it's not.
Wow, another word for subtraction is division.
Repeat it.
Minus.
Different.
Oh,
This is set difference
difference, yeah.
or exclusion. So this simply means I'm excluding 2 from that set. This is just extra knowledge. I didn't see a problem this complicated in your homework system. But do we understand that? Yes? So I can't simply draw the y and z components and define just for an x plane. If I want to, just like we would do with piecewise functions. If it doesn't exist, we can exclude it. But if I place the restriction that all 3 components have to exist, then I need to account for the existence of every single one of them. Yes, and in this case, all of them would exist. I forgot to draw the blue shape. Cosine 2t has no issues. Sine t will have problems at every multiple of time. And the rational function will have an issue only at one value, which is 2. I'm excluding 2. I'm writing this as the union of integrals. If you are not a mathemaker, you don't have to worry about this fancy little word. That's called partition, right? You're partitioning a bigger set into smaller subsets.